All right, guys, today we're going to work with some inverse functions. This is section 2.7 in your book. So what does it mean to be an inverse function? So this is talking about how the composite f of g of x and g of f of x should both equal x for every x in your domain. So that's what we're going to test. If we want to show that these are inverses, then we need to test f of g of x, and we need to make sure it becomes x. So g of x is x plus 7 over 4, so we want f of x plus 7 over 4. So that means to go to f and plug this in. So we're going to go to f, and we're going to plug this in. 4 times x, which is x plus 7 over 4 now, minus 7. Solving that out, those will cancel. We've got x plus 7 and then minus 7, and we wind up with x. So that's good. Now we got to try it the other way and make sure we still wind up with x. So now I'm going to come over here. We want g of f of x. So we're going to go ahead and replace f of x, right? We want g of, instead of f of x, we're going to write 4x minus 7. So we want to go to g and plug this in. So we're going to go to g, and we're going to plug this in. So we've got 4x minus 7 plus 7 over 4. And what do we got? 4x over 4. All right, those cancel. And we're left with x. So yes, these are inverse functions. Yes, these are inverse functions. You can also find the inverse. If I give you something, you can find the inverse. Here's your steps. So the first step is, remember f of x is a fancy y. So we're going to write it out as y. And then you actually switch your x and your y. So we're going to make this an x, and we're going to make this a y. And you solve for y. Solve for y. So we're going to subtract 7 from both sides. And we're going to divide both sides by 2. And you're done. Now you do go back and make this an inverse. So instead of y, we're going to put f inverse of x. And then x minus 7 over 2. There's my inverse. Next one, let's try it again. So again, same steps. Y equals 4x cubed minus 1. We're going to switch our x and our y. And we're going to solve for y. So we're going to add 1 to both sides. We're going to divide both sides by 4. And then to undo a cube, you take the cube root. So we have the cube root of x plus 1 over 4. And then you just have to go back and make this the inverse function. So f inverse. The inverse of f of x is the cube root of x plus 1 over 4. And there we go. Let's try one more. Same concept. Y equals 3 over x minus 1. Switch your x and your y's. We're going to solve for y. Add 1 to both sides. Let's go ahead and multiply both sides by y. So I have y times x plus 1 equals 3. And again, to get y alone, I'm going to divide both sides by x plus 1. So we have y equals 3 over x plus 1. And change it back to that inverse, and you're done. 3 over x plus 1. The next thing we're going to talk about is the horizontal line test. So the horizontal line, remember we did vertical line test to tell if it was a function? So if you look here, vertical line test, yes, it's a function. Vertical line test, yes, it's a function. So it's passing the vertical line test. The horizontal line test tells you if the inverse is a function. So if you look here, horizontal line test, my inverse is not a function. My inverse is not a function. So this is a function, but the inverse will not be. Horizontal line test, yes. Right? Yes, your inverse is a function. Horizontal line test, yes. Yes. The inverse is a function. Okay, so horizontal line test, vertical line test is to tell if this is a function. Horizontal line test tells you if the inverse is a function. Let's start some graphing here. So we have two line segments, -2, -2. Let's graph some inverses. And then we have -1, 0. Don't do it to me. I'm going to graph. And then -1, 0 to 1, 2. I know this looks really bad. So there's my function. And then it wants us to graph the inverse. Understand what's going to happen? These are going to flip-flop. So -2, -2 is still going to be -2, -2. We're still going to start there. But -1, 0 is going to be 0, -1 now. Come on. There we go. Again, that's still going to be the same. 1, 2 is going to be 2, 1. Maybe. There it goes. And you should see them, that line of symmetry, right? You should see that y equals x kind of splits those functions in half. All right, that's a line of symmetry. But there's your function and its inverse. Now this one, sometimes you have to restrict the domain. You have to restrict the domain. And what I mean by that is maybe the original was not, the function did not have an inverse. So if you look here, x squared plus 1, x squared plus 1, remember x squared was that parabola? X squared plus 1 is that parabola that just moved up 1, right? This doesn't pass your horizontal line test. So the inverse is not a function. If you restrict the domain, then your inverse is a function. Because if I restrict the domain to just x is greater than or equal to 0, I'm only working with this part of the graph. And that does pass my horizontal line test. So what they did in this one is they restricted that domain. They just took a piece of that parabola so that we did have an inverse. So we're going to go ahead and graph. So again, we only want that little piece where x is greater than or equal to 0. So if 0 is plugged in, we get 1. So 0, 1. Here's my vertex. This is going to fight me the whole time. If I plug in 1, 1 squared is 1 plus 1 is 2, so 1, 2. If I plug in 2, 2 squared is 4 plus 1 is 5, 2, 5. Just so we get a couple points going on here. Remember, that's that piece of the parabola. Okay, that's that piece of the parabola. Now we're going to go ahead and graph its inverse. Again, all we have to do is flip-flop those points. So this was 0, 1. Now it's going to be 1, 0. Oh, come on. This was 1, 2. Now it's going to be 2, 1. This was 2, 5. Now it's going to be 5, 2. And you should see that square root function, right? Because think about it, they are inverses. A squared function and a square root function are inverses. And again, you should still see that line of symmetry through that line y equals x. So sometimes you have to restrict the domain to make sure that your function has an inverse. And that's it. Bye, guys.